Welcome back to this video lecture series on data structure and algorithms. Today we'll be discussing on the linked list and array representation of a binary tree. So let's start. So the main concern thing about this discussion is the way we implement the representation in terms of coding. So before going to that programming part, let us just know that what we will be using in case of linked list and array. So when we will be using linked list, we must keep in our mind the structure of the node of the linked list representation. So for binary tree, in the structure of the node, we'll have three fields. One will be a data field, and it can be an integer type or anything else. The other two fields will be a pointer to the node field, left and right. It means that the left, it points to the left child node of a parent node, and the right pointer, the struct node star right, it points to the right child node of the parent node. Next comes is when we will be doing the array representation, we have to keep in mind some rules. So the thing is that if we decide that the array indexes in which we will be storing the node values of a binary tree, the array indexes starts from 0, then for a parent node having an index value of p, the left child node is stored at index 2p plus 1 and the right child node is stored at index 2p plus 2. And if the array indexes starts from 1, then for a parent node having an index value of p, the left child node will be stored at index 2p and the right child node will be stored at the index 2p plus 1. So these are the things that we have to keep in mind when we will be doing the programming part of the representation. So let's now go to our IDE. So I have opened my IDE here, and here in the programming part, what I'll do, I will first create the binary tree using the linked list. That is, I'll represent the binary tree in terms of linked list representation, and then I'll go for the array representation. So for the linked list implementation, we will first define the structure of the node. So struct node. Now here we'll have three fields. One will be this data, next will be the pointer to the left child node of a parent node, so we will name it as left, and the next one will be a pointer to the right child node. So this is the structure of the node. Now here for the linked list representation, we'll simply create a root node first. So root is equal to, here we will use a function new node, and I'll give the value of the node that is to be stored in the data field. So I'll first actually define this new node function. So the return type will be struct node star, and the argument will be of an integer type. So here the same thing, we'll just have to allocate the memory. So struct node star, let's say the name of the variable is temp, and here it will be struct node star, then malloc allocation, so size of struct node. Now the assignment, so temp data will be assigned with the value of I, and the pointer fields will be assigned with null values. Temp right, okay, right will be also null, and we'll simply return this newly made node temp. So here now I'll create the tree. So it's just creating a node and storing it. So I'll just do this, root left a new node, let's say it has a value of 2, then the right child of the root, so this will be new node and let's say value of 3, then we want to create two childs of the left child node of the root node. So what we'll do, we will write root left, first left, again a new node creation. So this will be say value of 4, and lastly root left right will again be having this new node and a value of 5. Now in order to show the linked list representation, we'll use the in order traversal representation of binary tree and a new line. So here we will actually use a function called in order, and we'll pass this root as the argument. So let us just define this in order function, which is very simple. So the return type will be void, and here the argument will be having a type of struct node star, let's name it R. So here we first have to check whether R is null or not. If it is null, then we'll simply type return. Otherwise, for this in order traversal, we'll operate this function on the left child of the root node, then we'll print the value %d and space, and then this will be R data, and lastly again I will actually operate this function on the right child, and that's it. So now I will use the array representation. So first let me just print out a message that says the array representation of the binary tree, and then a new line. Here I will use a function, let's call it array wrap, and I'll pass two arguments here. First one is the root of the binary tree, and lastly is the position, the index position from which the array starts. So I'll pass 0 here because I have taken this. So now let's define this array rep function. So the return type of this function will be void, and the arguments will be like struct, then node star R, and a position int p. So here again first I'll check if R equal to null, then I'll simply say return. Now when we are doing this array representation, we have to take an array, right? So for that I'll take this array as a global variable. So I'll take int array, let's say the size of this is 100. I'll also take a variable, a global variable called count. So now here in this function, if the root node is not null, what I'll do first is array of p will be assigned with the value of the R data, and then I'll check for the left and right childs of this root node. So if there is a left child, then what I'll do, array of 2 into p plus 1, and this will be R left data, and if there's a right child of the root, then this will be a bit different from this line of code, but almost same. So I'll just copy it, paste it. So here this will be right, and here this will be 2, not 12, 2. So this, And lastly, I will actually store this value in the counter variable, which is 2p plus 2. The reason for doing this is very simple, and I'll tell in the later part of this video. And now after doing this, we'll simply do the recursion calls of this function. So array rep, now this will be first operated on the left child, and the position here will be this. So here comes, okay, this is, yeah, until this, so this is right. And also I'll operate this function on the left right child node. This will be 2 and this will be right. So array representation function is well defined. Lastly, I'll use a loop to print the array here actually. So for that I'll need a variable called anything I, let's say. So for I is equal to 0 and I less than count I plus plus, let me do this is equal to, yeah. So if this is the case, then I'll print %d new line, and this will be array of I. That's it. Okay, so one thing is that why I used this count variable is obviously to keep a track on the loop iterations, that I don't want the loop to be continuing for an eternal time. And why I did this assignment here, the thing is that it may occur when we are doing the array representation is that all the elements are not stored contiguously, like 0 1 2 3 4 5 like this. There may be some array indexes at which no data is getting stored, and for that case what this array does, it stores 0 by default. So when we will be running this program, we'll see that in the array representation there are too many values with the data value of 0. It means that there is no node at that index, and that is why to have a proper number of loop iterations, I have stored the maximum possible index in this count variable. So let's now run this program and see how it worked. Okay, so the output is here. Well, as we can see, the in-order traversal is properly done. So this is the linked list representation. Now, when we observe this array representation, we can see 2 zeros here. It reflects that there are no data values of or there are no nodes to be placed at these indexes. And if we analyze, so we started the array with the 0 index and we had 2 childs for the parent node 1. So for p is equal to 0, the 2 childs will be having an index of 1 and 2. And for this left child node, which is at index 1, we have 2 more children. So if p equal to 1, the 2 children will get an index value of 3 and 4. And the exact thing is done here. The 4 is, which is the data value of the child node of the node of having value 2, this is stored at the 3rd index, and the right child node of that node with the value 2 is stored at the 4th index. So this was the array and linked list representation of a binary tree. Thank you for watching this video and staying with us. See you next time.